Good morning, everyone. So let us go with the class of or we stopped yesterday, like a cyclic structure of your glucose. So from that, we need to take up the class today. Okay. So then, okay. Fine. So yesterday we wrote alpha and beta structures. Okay, alpha and beta structures of glucose. So today we need to know and we need to discuss about how this furanose and pyranose will be differentiated from their structure and how we can write it. So that and all we need to study now. Okay, fine. So we have the word called pyranose and furanose. Okay. So what do you mean by pyranose and furanose? Okay, what do you mean by pyranose and furanose? So this pyranose having an six-member ring, and as such furanose seems to be five-membered ring. Okay, pyranose is six-membered ring and furanose is your five-member ring structure. Okay, then next, it is derived. Pyranose is derived from the aromatic compounds. This is also derived from the same source. So both are derived from the aromatic compounds. And what is the name of that aromatic compound means? For your five-member ring, that is furans, for your furans, it's a furan. Here, pyran. Okay. From the word pyran, it is an aromatic compound. Your pyrons are derived, and from your furan, your aromatic compound derived as an furan. That is your carbohydrates. Okay. So, and it's a six-member ring. Six-member ring, we are writing like this. This O represent the glycosidic bond. Okay, glycosidic bond. And here, furans is an five-member ring and it is represented like this. And same, this is said to be as glycosidic bond. Okay. Are you getting my point? Fine. Next, we need to know Haworth structure of glucose. Haworth structure of glucose. So actually, this is basically from the scientist called W.N. Haworth. Okay, W.N. Haworth. He proposed a three-dimensional model that is called as Haworth project. Okay, Haworth project formula. So this can be asked for 1 mark question. What is the theory proposed by Haworth? Write it down. What is theory proposed by Haworth? Okay, so that is Haworth project formula. So how he did, what he did means he is using the structure arrangement of glucose by an ring format. Okay, so we need to know how he is going to explain the structure of glucose. So first he need to convert the open chain structure to an closed chain structure, that is Fisher structure. Fisher, Fisher structure to Haworth structure. So they'll ask you, write the Haworth structure of sucrose, glucose. This is for 2 marks question. This is an compulsory question, and this definitely they'll ask you. Write the Haworth structure of sucrose, of maltose or lactose, any disaccharide. They'll ask you. This question is compulsory question. So this is 2 marks. So if you know this and this, so 3 marks is in your pocket. So next, he proposes the glucose into 2 diversional structure of Haworth, that one is alpha glucopyranose structure and beta glucopyranose structure. Okay, he classified. Okay, you can do one more thing. He just proposed the glucose into pyranose and furanose structure. Okay, pyranose and furanose structure. In pyranose, he divided into alpha glucopyranose and beta glucopyranose, and fructose also alpha glucofuranose and beta glucofuranose. You should write nan jote ನೀವು ಬರಿಬೇಕು. You should write along with me. Okay, then only you can able to understand the concepts. Are you getting my point? Yes, fine. So this is the thing over here. So glucose, he classified. Who classified? Haworth classified the glucose based on their structure and arrangement in the ring in the 2 different ways, that is pyranose structure and furanose structure. Pyranose structure, as we know, it's of 6-membered ring, and furanose structure is of 5-membered ring. In that pyranose, he classified into alpha glucopyranose and beta glucopyranose. In furanose also, alpha glucofuranose and beta glucofuranose. Let us know how he is going to arrange the structure from the open chain structure to the closed chain structure. So first I'm going to write how he is differentiate the open chain structure and closed chain structure. This is glucose open chain structure. New glucose structure ಎಷ್ಟು ಸಾರಿ ಬರೆದ್ರೂ ಸಾಕಾಗಲ್ಲ. You need to write. Then only you can able to learn. So if the position of the OH group is of your right side, that is alpha, same I am going to write the beta structure. This is not Fisher structure. This is Haworth structure. This is Haworth open chain structure. In our Fisher structure, it is different. Okay, Fisher structure I can show you. Yeah, this is your Fisher structure. Okay, this is not a Haworth structure. Yes, this is your Fisher structure. This is your Fisher structure. Fisher structure ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾನೆ ಅವನು ಅಂತ ಹೇಳಿದ್ರೆ, third carbon is going to change ಅಂತ ಹೇಳ್ತಾನೆ. But Haworth saying the first carbon OH and H plus group, based on that he classified the presence of OH. If it is downside, it is alpha. If it is upside, it is beta. I am going to explain you, but you should remember that Fisher going to say the alpha beta based on third carbon. Haworth say the H and OH position based on the first carbon. Okay, so now this is alpha and beta. I'm going to write the open chain structure, sorry, ring structure for the same structure. Okay, okay, so this is the structure. So from the 5th carbon, you will drag the OH, and O is sit in middle, and it gives that H to O, and it will become like this, and it will make the bond like this. Okay, this is your alpha structure of Havard. So this is for your sake. This is not going to ask you for the examination. They'll ask you the ring structure, the 6-membered ring like this. We need to write it and show you. I'll show you. This is for your sake. So this is the open chain structure of your Haworth glucose, but Haworth doesn't propose the glucose structure in an open chain. He proposed in a ring chain. If we open that ring, we can see like this. Okay, it's totally different, or the position of the H and OH is different from your Fischer structure. Okay, so the next thing is this is the ring structure. Okay, this is a ring structure, and but we are writing in an open way. Okay, but we are writing in an open way. So now next we are writing and have our the original ring structure of alpha and beta. So as I told you, this link will show you the presence of C. Can you see? The first carbon position OH, if it is in the downside, that is alpha glucopyranose. I'll write the same thing in a wider manner for beta. So if the position of the OH in the first carbon, if it is in the top of the axis, that is beta glucopyranose. Okay, can you able to understand? ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಪ್ಪ? You just copied the structures. So first you should copy the structure of this and this, then write this. Copy down fast. Kavya, can you see now? It's adjusted, right? Initial for 2 to 3 minutes, it will happen like this because of internet. It is going blur and this thing. But I'll focus the point. Okay. You can see it now, right? Because I'm also using the one more device to see how it is look like. So yeah, it is like showing like this. Just a second, I can do one more thing. Does it okay now? Does it okay? Yeah, okay, Kavya. Now it's in proper direction, right? Shall I go further? I wrote this. I wrote this entire structure. Yes. ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿ ಬರೀರಿ ಅದೆಲ್ಲ ಓಕೆ ಹತ್ರ ನೋಡಿದ್ರೆ ಕಣ್ಣು ಹೊಡೆಯುತ್ತೆ ಓಕೆ ಓಕೆ ಫೈನ್ ಫೈನ್ ಆಲ್ರೆಡಿ big man. This is like a cyclic structure now. Yes, Gokul, it is cyclic structure. Okay, Sujana, continue. Meghana, clear, Anisha. Now is that topic right to corner beta? Yes, this one is beta. This is beta glucose, and this is alpha, and in top, this one is alpha, and this one is beta. Okay. Glucose is there now, man. Therefore, the third carbon, it should be C. Yes, Megha, that only I'm saying. This is the, actually, Havard doesn't propose an open chain structure. But I just open it, your ring structure into open chain structure. He didn't propose any open chain structure. I just touched it up. Okay, you are right. In the open chain structure, the third carbon should be HCOH. OH should be in the right side. Then only we can say that is of beta. Sorry, that is of alpha. But according to the Havard, he didn't propose the open chain structure of glucose. He proposed only the closed structure, the recyclic structure of glucose. I just cut it down this point and I just split it up like this. Okay, Meghana? For the open chain structure, not for Havard, your answer is right. Can I continue? Okay then. Next we have fructose. So fructose can you able to get now at least what we are saying or what we are teaching? Can you able to understand now? Otherwise, also are you facing any difficulties to understand in this lesson? Because if we are writing, I think we can able to get the points, like how we can write that and all. We can easily make it out. But when you are keeping the slide, it's difficult to mug up in. Please reply fast. Okay, I'll fructose. Yes. Yeah, okay, Josephine. Yes, Srijan, that's right. If we are writing, we can understand. If we didn't write, we can't understand. I hope you are maintaining your running notes, and I'll definitely check whenever the college reopens. I think it will open by the September. So in my first class, after introduction, that is the first work I'm doing, that I will check your running notes. That is for definitely. If those who are not writing, please maintain running notes. If you are not having that running notes, I'll take a serious action. Okay, then fructose. So first let us know something about fructose. Fructose is an monosaccharide. Yes, it is a monosaccharide. Then next, it is found in the plant source. Okay, it is found in the plant source and it having the sweet taste. Okay, it having the sweet taste. It is from the monosaccharides. It's from the plant source and it having the sweety taste. And it is present in dry fruits Okay, it is present in dry fruits. It is in white crystalline structure. White crystalline structure. Okay, white crystalline structure. And it's an odorless. These are all the features of your fructose. And it is soluble in water. Soluble in water. Actually, I'm sorry, today I'm getting so many messages. That's why you are having the sound of vibrating. I'm sorry for that. Monosaccharides. Yes, fructose is a monosaccharide. It is extracted from the plant source. Yes, right. And it having the sweet taste. It is present in the dry fruits. And it exists in the form of white crystalline structure with an odorless, and that is soluble in water. Okay. And this fructose having the basic name, okay, basic name called LEVULOSE, levuose. This is the basic or derived name. After the structuring, actually this is going to ask for 1 mark in the CET exam. CET NEET exam is the important word. Levinose, LEVULOSE, levinose. This is the derived name. Levinose is the derived name. When they start to structurize, they know that this is most oftenly present in your fruit. This is called as fruit sugar. Sorry, I forgot to say. This is called as fruit sugar. So after the presence of fruit in a bulk amount, in a more amount, they gave the name called fructose. The basic name of your fructose is your levulose. The basic name of your fructose is your levulose. Okay. Then the structure of your fructose. I'm not saying I'm writing the Harvard structure. Just I'm writing the structure of your fructose. ದೊಡ್ಡದಾಗಿ ಬರೀರಿ ಅಂದ್ರಲ್ವಾ CH2OH C double bond O CHOH COH H. Seriously, ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿ ಬರೆದ್ರೆ ಹ್ಯಾಂಡ್ ರೈಟಿಂಗ್ ಚೆನ್ನಾಗಿರಲ್ಲ because I don't know how to write it in a big manner. Please excuse me for that. Okay, Meghana, can you able to see now? Meghana? Is it Meghana or Kavya? I forgot the name. Kavya. Okay. This is your fructose structure. Fructose structure. Please copy it down. This is your fructose structure. You should notice one thing. In our glucose structure, we are going to write the aldehyde group in the first carbon. But here we are writing a ketonic group in the second carbon. Okay, in the second carbon, we are writing a ketonic group. And one more thing I need to ask. ಏನಕ್ಕೆ ಎಕ್ಸಿಟ್ ಆಗೋದು ಮತ್ತೆ ಬರೋದು ಎಕ್ಸಿಟ್ ಆಗೋದು ಮತ್ತೆ ಬರೋದು ಮಾಡ್ತೀರಾ? ಕ್ಲಾಸ್ನ ಕರೆಕ್ಟಾಗಿ ಕೇಳಿದ್ರೇನೆ ಪಾಠಗಳು ಅರ್ಥ ಆಗಲ್ಲ. You didn't get that. If you are regular, then only you can't understand some concepts. But if you are seems to be irregular, how can you understand? Almost the strength has been decreases. It's of 33, 34 like that. In them also, they were going and coming, they were left. Because you are thinking like whenever you are getting attendance, if you are leave the class also, no problem. I don't do like that. I'm just noted down those who are lefting. So Kiran C is left now. So I won't give you the attendance for him. Those who are maintaining the continuous presence in the class, for them only I'm giving. At least 40 minutes. Can't you stay in class? At least 40 minutes. I know it's of network issues, but immediately you can join. Immediately means, okay, within 2 to 3 minutes you can join. But also, anyway. So have I wrote this? Have I wrote this? Shall I go with the classifications of fructose? Shall I go with the classifications of fructose? Yes. Fructose having the structure of our fructose has been again classified into pyranose and furanose. Okay. And here also it's of alpha, beta. Here also same thing, alpha and beta. Are you getting my point? Fructose has been classified into the structure of, it's based on Haworth, I'm saying. Haworth. So Haworth classified the fructose into pyranose and furanose structure. Again, the pyranose has been classified into alpha, beta, furanose also alpha and beta structure. Pyranose means, yes, as we know, it's a 6-membered ring, and furanose is a 5-membered ring. This is 5, this is not 6. This is 5-membered ring. Okay, then we're having only 10 minutes, so I need to complete and I will complete. So here I'm going to write the open chain structure of your alpha, and you need to write this, and I'll write, sorry, open chain structure with the link structure. So, and I'm going to write the alpha structure of furanose, and you need to write the beta structure. Okay, start copying down. This alpha D plus pyranose fructose, or you can say pyranofructose. You can write pyranofructose. Pyranofructose. Then change it to beta. How you need to change? Everything remains the same. This position should be changed because Haworth is saying from the first carbon, if the OH and OH position has been changed, it will show you the alpha beta structure. So this is alpha D. I'll tell you now. This is alpha because of the presence of right side of OH. D means it will rotate towards your clockwise direction. As I inform you how to rotate D or L and ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, because of you can judge that presence of OH, the number of OH group present in which side, that will give you the presence of rotation. So if it is 3 OH is present in your right side, that is D. If it is present in your left side, that is L rotation. And plus we are writing this, plus means to say the spinning in the positive moment, spinning of the molecule. So you need to write it for beta D minus pyranofructose. Okay, have I wrote? Finish. Shall I go with the fructose structure, sorry, furanose structure? I'll show you how to write the closed chain structure for this. You need to learn both the structure. Okay, this is your alpha D plus pyranose fructose. So you need to write for this like this also and like this also for your beta. Have you finished? Have you finished? Sorry. Then furanose structure, only we have 6 minutes. Write it fast. Okay. Furanose again, we are writing in alpha and beta forms. Okay. So here I'm writing the open chain structure. Sorry, open ring structure, we can say. Yes, open ring structure. From the first carbon to the, from the second carbon to the fifth carbon. Second carbon to the fifth carbon linkage. Okay, this is called as alpha furanose fructose. You can see the sixth carbon is attached to the fifth carbon and first carbon attached, first carbon attached to the second carbon. This is called alpha fructose. And here you need to write beta fructose. You just change this position. You should write the OH here. You should write the OH here. Are you writing? Barita idra? So I'll write the same structure in ring format. Otherwise, you can write like this also. ಈ ತರ ಕೂಡ ಬರಿಬಹುದು. You can write as your wish. Same. ಅಂದ್ರೆ ಇದನ್ನ ಈ ತರ ಮಾಡೋದಷ್ಟೇ. Both are same. Both are same. Okay. These two are the close ring structure of alpha fructose. Both are same. Are you writing the beta structures? Have you writing the beta structures? Have you writing the beta structures?